In 2009, Western intelligence agencies made a discovery that sent shockwaves through the Pentagon and changed nuclear strategy forever. Hidden near the holy city of Qom, buried deep inside a mountain, Iran had constructed a secret uranium enrichment facility called Fordau. This wasn't an ordinary nuclear site sitting in an open valley vulnerable to airstrikes like facilities in Iraq or Syria. Fordau was engineered to be invincible, protected by 80 to 90 meters of solid granite and reinforced concrete. For Iran's leadership, this mountain fortress represented the ultimate insurance policy for their nuclear ambitions. They believed no bomb on Earth could reach them, that physics itself would protect their centrifuges spinning uranium toward weapons-grade purity. But they were wrong. On June 22, 2025, the United States proved that no bunker, no matter how deep, can hide from American firepower. Operation Midnight Hammer would become the largest B-2 operational strike in United States history. 7 stealth bombers flew 18 hours from Missouri to Iran, dropped 14 of the most powerful conventional bombs ever built, and changed the rules of underground warfare forever. This is the story of how physics and American engineering conquered a mountain. To understand why Fordau terrified Western military planners for over 15 years, you need to understand what makes it different from any other nuclear facility on Earth. Iran's larger enrichment site at Natanz sits only 8 meters underground, easily within reach of conventional bunker-busting bombs. But Fordau was built inside a mountain originally used as an Islamic Revolutionary Guard Corps missile base. Construction began in 2006, and the facility was designed from day one to survive anything short of a nuclear strike. The main enrichment halls sit between 80 and 90 meters beneath the surface, protected by layers of limestone, dolomite, and granite. Some geological analyses suggest certain sections could be buried even deeper, potentially exceeding 100 meters. The rock composition itself presents a nightmare for weapons designers, with compressive strength reaching up to 25,000 pounds per square inch in some areas. To put that in perspective, standard reinforced concrete typically has a compressive strength of only 5,000 pounds per square inch. The facility houses approximately 3,000 centrifuges spread across 2 main halls, including advanced IR-6 models capable of rapid uranium enrichment. While Natanz enriched uranium to low levels of 3 to 5%, Fordau was Iran's primary site for higher-level enrichment. In 2023, International Atomic Energy Agency inspectors discovered uranium enriched to 83.7% at Fordow, just steps away from the 90% required for nuclear weapons. The facility's location near Qom, one of the holiest cities in Shia Islam, added another layer of protection, as Iran calculated that striking near a religious site would trigger massive backlash across the Muslim world. Winding mountain roads lead to tunnel entrances carved directly into the rock face, giving access to the underground centrifuge halls. From the surface, almost nothing is visible except ventilation shafts and a few support buildings. For years, military analysts concluded that only one country possessed the capability to seriously damage Fordau. And even then, success was far from guaranteed. To crack a mountain, you don't just need a bomb, you need a weapon that defies conventional physics. The GBU-57 Massive Ordnance Penetrator is not simply a large explosive, it is an engineering marvel designed to dig its own grave before detonating. At 30,000 pounds and over 20 feet long, it weighs as much as a fire truck and stands taller than a 2-story building. Most bombs are designed with maximum explosive payload in mind, typically 80% explosive and 20% metal casing. The GBU-57 inverts this ratio completely, built with 80% hardened steel alloy and only 20% high explosive. The casing is constructed from Eglin steel, a special high-density alloy developed specifically to withstand the extreme pressures of deep penetration. This design philosophy reflects a fundamental truth of bunker busting. The explosion doesn't matter if it happens outside the target. The bomb must survive the impact, burrow through dozens of meters of rock and concrete, and only then detonate. According to the United States Air Force, The GBU-57 can penetrate up to 60 meters of earth or approximately 18 meters of reinforced concrete. Some estimates suggest penetration of up to 40 meters through moderately hard rock formations. The weapon uses GPS and inertial navigation systems for guidance, achieving precision within a few meters of its target. Look at the tail fins on this weapon. They aren't standard solid metal wings like on conventional bombs. They are lattice fins, grid structures similar to those on SpaceX rockets, designed to fold flat inside a bomber's bay and snap open in the airstream. These fins steer a 30,000-pound projectile with surgical precision despite its massive size. The warhead contains over 5,300 pounds of enhanced blast explosives, delivering more than 10 times the destructive power of its predecessor, the BLU-109. But perhaps the most sophisticated component is the smart fuse system. This fuse can detect structural voids during penetration and time detonation for maximum internal destruction. It can be pre-programmed to detonate at a specific depth, ensuring the explosive force is delivered exactly where it will cause the most damage. The development of this weapon began in the early 2000s, driven by lessons learned during the Iraq War when existing bunker busters failed to destroy fortified military bunkers. Defense Threat Reduction Agency personnel spent over 15 years studying Fordow's vulnerabilities, monitoring every ventilation shaft, electrical system, and equipment movement. According to Chairman of the Joint Chiefs General Dan Kane, these specialists literally dreamed about this target as they slept. But even the most powerful bomb is useless without a way to deliver it. The B-2 Spirit stealth bomber is the only aircraft in the American arsenal capable of carrying the GBU-57 into combat. With a wingspan of 172 feet and a flying wing design that eliminates all vertical surfaces, the B-2 appears on radar screens as nothing more than a small bird. Notice the complete absence of vertical tails, rudders, or stabilizers on this aircraft. Every vertical surface on a conventional plane reflects radar waves back to the enemy. The B-2 simply deleted them. The aircraft's outer skin is coated with radar-absorbing materials, and its curved surfaces prevent sharp radar echoes. Its 4 General Electric F-118 engines are buried deep within the airframe, with heat-dissipating exhaust trenches that mask thermal emissions. This makes the B-2 nearly invisible to both radar detection and infrared tracking systems. The bomber can carry up to 40,000 pounds of ordnance in its 2 internal weapons bays, specifically designed to accommodate 2 GBU-57 bombs. With an unrefueled range exceeding 6,000 nautical miles, the B-2 can strike targets anywhere on Earth from bases within the continental United States. With aerial refueling, that range extends beyond 10,000 nautical miles, enabling missions lasting over 40 hours. The aircraft includes amenities rarely seen in combat planes: a bed, toilet, microwave, and mini-fridge for its 2-person crew. One pilot can rest while the other maintains control during extended missions over hostile territory. Only 19 B-2s remain in active service today, each valued at over $2 billion. They are expensive, maintenance-intensive aircraft requiring climate-controlled hangars to preserve their delicate stealth coatings. But for missions requiring deep penetration of sophisticated air defenses, the B-2 remains irreplaceable. Iran's air defense network includes Russian-made S-300 systems and possibly S-400 batteries capable of engaging targets at distances up to 400 kilometers. A conventional bomber like the B-52 would be detected and destroyed hundreds of miles from Fordau. The B-2 is built to fly directly over these systems without ever being detected. Even with stealth capabilities, no aircraft flies into hostile airspace alone. The F-35 Lightning II served as the eyes and ears of Operation Midnight Hammer, penetrating Iranian airspace before the bombers. The F-35 carries an advanced electronic warfare suite called the AN/ASQ-239 Barracuda, providing 360-degree threat detection. This system can identify, monitor, and respond to enemy radar systems while simultaneously providing jamming and countermeasure capabilities. The aircraft's mission was not to drop bombs, but to suppress enemy air defenses and clear a path for the vulnerable bomber force. Using stealth sensors and targeting systems, F-35 pilots detected and destroyed surface-to-air missile sites throughout the strike corridor. The Air Force later confirmed that F-35s were the first American aircraft to penetrate Iranian airspace and the last to leave. Flying alongside the F-35s were EA-18 G Growler electronic warfare aircraft. The Growler carries the AN/ALQ-99 jamming pods, capable of overwhelming enemy radar with electromagnetic noise across multiple frequency bands. These pods have small propellers on the front that generate their own electricity because the jamming equipment demands more power than the aircraft's engines can spare. When the Growler activates its full jamming suite, enemy radar operators cannot distinguish a stealth bomber from a thunderstorm. Together, the F-35s and Growlers created an electronic fog that blinded Iran's air defense network at the critical moment. On June 21, 2025, 7 B-2 Spirit bombers lifted off from Whiteman Air Force Base in Missouri. A second group of B-2s flew west over the Pacific toward Guam as a deliberate decoy to confuse open-source intelligence trackers. The strike package flew east across the Atlantic and Mediterranean, refueling mid-air 3 times over 18 continuous hours. Communications were kept to an absolute minimum, with pilots flying pre-programmed flight plans loaded onto hard drives before departure. Over 125 aircraft participated in the mission, including dozens of refueling tankers and intelligence platforms. As the bombers approached the Middle East, they linked up with F-35 and F-22 fighters in a complex, tightly timed maneuver requiring exact synchronization. At approximately 5 in the evening Eastern Time, a U.S. submarine in the Central Command Area of Responsibility launched more than 24 Tomahawk cruise missiles against surface infrastructure at Isfahan. The cruise missiles served as both a strike weapon and a distraction, drawing attention away from the approaching stealth bombers. The F-35s pushed ahead of the bomber formation at high altitude and high speed, sweeping for enemy fighters and surface-to-air missile threats. American forces employed multiple deception tactics, including electronic decoys, to further confuse Iranian air defense operators. At approximately 2:10 in the morning local Iranian time, the lead B-2 opened its bomb bay doors over Fordow. For exactly 3 seconds, the doors remained open as 2 GBU-57 Massive Ordnance Penetrators dropped into the darkness. The bombs fell through the thin mountain air, lattice fins guiding them toward the precise GPS coordinates programmed before launch. They accelerated to near supersonic speeds, building the kinetic energy needed to punch through 80 meters of solid rock. The first bomb struck the mountain's surface and held together, its hardened steel casing surviving forces that would vaporize ordinary munitions. It burrowed downward, 10 meters, 20 meters, 50 meters, passing through granite and concrete until reaching the underground chamber. Only then did the smart fuse detect the void and trigger detonation, unleashing over 5,000 pounds of high explosive inside the enrichment hall. A second bomb followed the path carved by the first, penetrating even deeper into the damaged structure. This double-tap doctrine ensures that even if the first bomb fails to reach the target, the second can exploit the breach created by its predecessor. In total, the U.S. dropped 14 GBU-57 bombs across Fordau and Natanz, delivering approximately 75 precision-guided weapons over 25 minutes. Not a single shot was fired at the American strike package on the way in or out. Iranian fighters never took to the sky, and surface-to-air missile systems never engaged. Chairman Kane later described the mission as inflicting extremely severe damage and destruction on all 3 targeted facilities. In the days following Operation Midnight Hammer, satellite imagery revealed the devastating effectiveness of the strike. Small entry holes in the mountain's surface belied the catastrophic destruction occurring deep underground. Sentence: Israeli military officials told the New York Times that Fordau was substantially damaged, but not completely destroyed. Pentagon spokesman Sean Parnell stated that the strikes degraded Iran's nuclear program by 1 to 2 years. Iran's foreign minister admitted in an interview that no one exactly knows what has transpired in Fordau. Equipment to assess damage and begin recovery operations was deployed to the site within days, but the true extent of the destruction remains classified. The IAEA's Rafael Grossi confirmed that almost all sensitive equipment at the targeted facilities was destroyed. For Iran, the strike shattered a fundamental assumption that had guided their nuclear strategy for 2 decades. They had believed that burial depth alone could protect their most valuable assets from American air power. Operation Midnight Hammer proved that assumption catastrophically wrong. The message to the world's other aspiring nuclear powers was equally clear. North Korea's underground facilities, potentially buried even deeper than Fordow, now face the same existential threat. China's hardened command bunkers and Russia's strategic reserves cannot assume safety at any depth. The GBU-57 and its inevitable successors have rendered the concept of an invulnerable underground fortress obsolete. If you cannot hide under 80 meters of mountain granite, you cannot hide anywhere on Earth from American precision strike capability. The physics that Iran trusted to protect their nuclear ambitions became the very physics that destroyed them. In the calculus of modern warfare, there is no such thing as a safe place. There is only a place that hasn't been hit by 30,000 pounds of American steel yet.